So we are going to continue solving, okay? But today we're actually going to add in word problems. So the function or the equation will not be given to you. You're going to have to write the equation and then solve it, okay? So we're adding a whole extra step today. So we got to remember how to solve. So looking at number 1, we have 5 plus 7a equals 4a minus 13. There's no grouping, there's no multiplying, no combining like terms. We can go ahead and start putting my variables on one side and our constants on the other, okay? You got 4 pieces here. Which one would you like to move? The 4a? Okay, how am I going to move it? We're going to subtract it. And what are we going to subtract it from? The 7. Why? Yeah, they both have an a attached to them. So we're going to put those together. So my 5 is still here. 7a minus 4a gives me a positive 3a. And then we still have this equals to negative 13. So that sign in front of the 13 is going to stay with it. All right, now what should we move? So see how we have the a's already together on one side? So I want to move my constants to the other side. So what are we going to move? 5. We want to move my 5 to be with the 13. Okay, so we have 3a over here. Negative 13 minus 5 is what? Negative 18. So we have 3a equals negative 18. So we have my variables on one side, my constant on the other, and then our final step is to do what with that 3? How is the 3 attached to the a? Right now it's being multiplied, so we need to divide the 3 out. Because 3 divided by 3 is 1. That gives me 1a. So a equals, what is negative 18 divided by 3? Negative 6. Good. Good. And what's a sure way we can always check our answers if we really wanted to? Yeah, you can plug it back in. Use your calculator, plug it back in, make sure it works. You could do 7 times negative 6 plus 5, and then 4 times negative 6 minus 13. Maybe we'll get the same answer. All right? So that was more of like section 1 kind of stuff. Number 2 was more section 2 kind of stuff where we had brought in the grouping. So y'all said it earlier. When we have grouping or the parentheses, we're going to multiply. So we're going to do 3 times x, which is 3x, right? And then we're going to do 3 times 5, which is 15. We still have, oops, it's the wrong spot. We still have our plus 4 equals 2x minus 5. So the green up there is just the distribution, doing 3 times x and 3 times 5. Nothing else has changed yet. Okay, so I have 3 things happening on the left. What do you want to do? Can I combine any of those or any of those like terms? Which one? Which 2? Yeah, 15 and 4. 15 and 4 gives me 19. So if I combine like terms, my left side is now 3x plus 19, but we still haven't touched this 2x minus 5. So the left side had a lot to do. There was grouping, there was multiplying, there was combining like terms. Now I can finally move variables and constants to the other side. Which one would you like to move first? The 2x. How are we going to move it? And what are we going to subtract it from? The 3x. Good. 3 minus 2 is just 1. Am I going to write 1x? We usually don't. If you did, are you wrong? No. If you really want to put that 1 right there, go for it. It would not be wrong. Okay, that'd be perfectly fine. Okay, so we moved 2x, so minus 5 is now a negative 5. What are we going to move? Well, the X has already been moved, and there's only one X left over, so that's going to stay there. We're going to move I heard it. The 19, how am I going to move it? Yeah, minus 19. So we're left with X is now equal, what is negative 5 minus 19? What kind of a 24? There you go, negative 24. All right, so we're going to bring in word problems. We're going to have to create equations, and then we're going to solve them. Okay, do you have any questions about number 1 or number 2? And if you feel like you still need practice on that, I have a couple on the back that we can do. After we get through our word problem stuff, if you feel like you need more of this, we can do some more of this. Questions? We're okay? You don't have to be okay, but we're not like, if we're on the thumb scale, are we at least like in the middle-ish? Okay. All right, here we go. First word problem. Hot dog eating contest winners. Do y'all watch this on the 4th of July?
No.
Joey Chestnut? You don't know who Joey Chestnut is? He is a real person, and he wins the hot dog eating contest like every year. It's crazy. Huh? No, he's not, actually. So anyway, this is, the book does really good, like, bringing real life stuff. So they're not, like, making up someone buying 45 watermelons at the grocery store, because who does that? They're really good about bringing in, like, real-world situations. So suppose the men's and women's winners, so Joey, and I think her name is Mikey, possibly, Mackay, I don't know how to pronounce her name. They decide to compete against each other to make the competition more interesting. Joey will not start, I'm going to call her Mackay, until Mackay has eaten 15 hot dogs. Okay? It is Mikey? Okay. Do you know her? Mikey Sudo? Assume that Joey and Mikey eat at a constant rate throughout the competition. Based on the number of hot dogs eaten in 10 minutes by Joey and Mackay, how many minutes after Joey starts eating will they have eaten the same number of hot dogs? Okay? So, there's a couple things we gotta figure out here. They've told me up here how many they eat in 10 minutes. Joey's gonna eat 75 hot dogs in 10 minutes. Mikey is gonna eat 48 and a half hot dogs in 10 minutes. Okay? This is important information for us because it tells us that they are going to eat at a constant rate throughout the competition. Constant rate is very fancy for what math term, do you think? The constant rate. Think like, a fancy math word. Starts with an S. Ends in lope.
Slope.
Yes. Okay, so a constant rate is a way of saying slope. So we can find each of their slopes by taking their totals and divide them by how long was the competition? 10 minutes. So I'm going to take each of these. So Joey, I'm going to do 75 divided by 10. So he has a constant rate of 7.5 hot dogs per minute. So I'm going to say 7.5 M. 7.5 hot dogs per minute. And then we got Mikey. .45 hot dogs in 10 minutes. So her average is 4.85 hot dogs each minute. All right, what else did it tell me? Yeah, he's going to wait until she eats 15 hot dogs, right? So, we're going to do Mikey over here, 4.85 plus 15, because she's already going to have 15 before he joins her. And we want that to be equal to Joey's 7.5. Why am I making them equal to each other? Because it says how many minutes after Joey starts eating will they have eaten the same number of hot dogs. So that right there tells you it wants the equations equal to each other. So we have their two slopes, their constant rates. And then we're adding in the 15 that Mikey's going to already eat before Joey chimes in. So how long will it take Joey to eat the same amount as Mikey? What should we do? What do you think? We're going to solve this now. Let's subtract this to the other side. So that way my variables are together. All right, so my calculator friends, what is 7.5 minus 4.85? Come on, it said you need a calculator. You should have one. 2.65? 2.65? 2.65, all right. So we have 2.65 m equals 15. Now what do we do? Yeah, we're going to divide by 2.65. Remember, m is minutes. So how many minutes until Joey caught up with her eating the same amount? What is 15 divided by 2.65? divided by 2.65. 5.66, like repeating, and a bunch of other things. 5.66. Yes, 5.66. Okay. So in about 5.66 minutes, they would have both eaten the same amount of hot dogs. So word problems get word answers. Approximately 5.66 minutes. If you want to get more detailed, you could say approximately 5.66 minutes after Joey starts, will they have both eaten the same amount of hot dogs. But that's how long? That is how long. So in 5 minutes, he's already caught up with her. I mean, he's almost eating twice as fast. Not quite, but pretty close. Questions, comments, concerns? Okay. Moving on to basketball. Here we go. Nolan and Victor were two of the top scoring freshman players in a college basketball conference last season. The table shows how many points Nolan and Victor scored and how many games they played last season. The points Nolan and Victor scored this season will be combined with their points from last season to give them their total career points. This season, Nolan is hoping to catch up to Victor and have the same number of career points. Assume that Nolan and Victor play every game and score at the same constant rate as last season. Okay? So first thing we got to do is come up with an equation because it wants them to be the same, right? So when are they going to match their career points? What other keywords did it tell me like last time? They have a constant rate again. So how can I find their constant rate or their slope? Points per game. How am I going to do that for Nolan? Yeah, divide. Good. Points per game. So if he did 750 points in 30 games, that's an average of 25 points per game. So that's Nolan's slope. That's Nolan's constant rate. All right, and then we're going to do it for Victor also. So Victor, he did 782 points in 34 games. So his constant rate becomes, what is it, 23 points per game. All right, so constant rate, we got that for both of them. What else do we know about their constant rates? Yes.
Victor has more games played and more points. How come he has 23 and Nolan has 25?
Because, I mean, it was kind of a bigger number, but it was divided by more games. So his points are more spread out. So he did. So it looks like he did better, but he played 4 more games. It was a good question, though. How are they going to total their career points? What did they say they were going to do with it? The points they score this season will be combined with their points from last season to get their total career points. So we're going to add their constant rates to their points last season. Oops. Okay, so Nolan, he's going to get 25 points per game, and we're going to add that onto the 750 that he got last season. So what's it going to look like for Victor? That's what Nolan looks like. What does Victor look like? Okay, good. There's one thing you didn't say.
23p.
There you go. Good. And they are equal to each other, so that's why we had, because it wants them to be the same. When are their career points going to be the same? If they continue at that same constant rate and they add on to their points from last year, when will they match up? All right. So let's solve for P. Let's solve for how many games it's going to take for them to match up with each other. You ready? Okay. Here we go. I'm going to rewrite the problem. 25p plus 750 equals 23p plus 782. Is there any grouping going on? Do you see any parentheses happening? Nope. Okay. Are there any like terms that I can combine on the same side? Can I put 25p and 750 together? Can I put 23p and 782 together? No. So now it's time to start moving things to the other side. Which piece do you want to move first? 23p. How are we going to move it? Subtracting. Oop, come on, pen. There we go. So what do I have on this side now? What is 25p minus 23p? 2p. Plus 750 equals 782. What's our next step? Yeah, subtract our 750. So now we have 2p equals, what's 782 minus 750? 32. Our final step. Divide by 2 and get 16. Good. Divide 32 by 2 and we get p equals 16. So it will take 16 games for Nolan and Victor to have the same career points. Remember, word problems get word answers. It will take 16 games for them to have the same career points. So Nolan will, because Nolan's constant rate was higher, he does slowly match up with Victor's points total. If Nolan's constant rate was less than Victor's, would he ever catch up? No? Maybe. If it did, I mean, no, I don't think he ever would. Or it would take a really long time. If you already have more points and you have a higher constant rate, you're just going to keep getting higher, right? If you have lower points and a lower rate, your lines won't cross because one will go straight up and one will kind of even out. What's that? Yes. Questions on the front part of our notes before we go to the back? I want to do the geometry problems with y'all. Okay. I know you haven't taken geometry. That comes next for you. But we know some basic geometry. Like, do we know how to find the area of a rectangle? Yeah? How do you do that?
Like, what do you mean?
What's the formula to find the area of a rectangle?
If there's not like a number on it?
Just what's the general formula? Area equals, there you go, length times width. Like, just like in general, without the numbers. Like, where are you looking?
Yeah.
So an area of a rectangle is going to be length times width. Okay, why is my pen doing this? Come on. Length times width. There we go. I'll zoom in for y'all. And then the area of a triangle. Does anyone know that one maybe? I know it's been a hot minute. Area of a triangle is half of your base times your height. Why are we talking about this? Because it wants to know the value of x to make these two shapes have the same area. So we're going to do area equals area and then solve for x. So the area of my rectangle, I need length times width. What is the length of my rectangle?
X plus 4.
5 or x plus 4. Does it really matter? No. And then my other side is x plus 4, right? We're going to multiply those pieces together. So the area is going to be, I'm going to put 5 out here first. 5 times x plus 4. What is 5 times x?
5x.
5x, good. And what is 5 times 4? 20. So the area of that rectangle is 5x plus 20. That's step 1. Step 2. Find the area of the triangle. So I need 1/2 of the base, which is the 12, times my height, which they have labeled as 2x minus 6. Okay, we already did order of operations in this class, right? Parentheses, I can't do anything with 12. I can't do anything with 2x minus 6. I don't have any exponents. Next, we go into multiplying and dividing, whatever we see first. So I see 1/2 times 12 first. What is 1/2 of 12? What if I said that? 6, right? So that's 6 times 2x minus 6. Now it looks a lot like the one we just did. We're going to have to distribute that 6 and multiply. What is 6 times 2x?
12x.
There you go. Good. Is 12x. And then what is 6 times negative 6? Negative 36. So for my visual friends, we did 6 times 2x to get 12x. And then we took 6 and multiplied it by negative 6 to get negative 36. Okay, so we have my two areas. Why did I do that? What was the point? What do they want me to find? The value of x, so the two figures have the same area. So it wants area equals area. When do my areas equal each other? What would make that happen? So what was the area of my rectangle? What was the area of my rectangle? There you go, 5x plus 20. And it wants to equal the area of the triangle, which was 12x minus 36. Have I lost anybody? You can tell me if I have. Because when you get lost, that's when you're really quick to just shut down, and I just don't want that to happen. Okay? So it asked me to find the x value to make both areas equal to each other, right? So in order for me to make that happen, I need to know what the areas are. So that's when I found the area of my rectangle, which is length times width. And then separately, I found the area of the triangle, which I told you was 1/2 times the base times the height. Okay? So once you found the individual areas, now it wants them to be the same area. So now we're making them equal to each other. Yes?
It's not the math that I struggle on, it's the remembering like all.
So we're going to try to keep like doing more and more repetition to kind of help that, make that connection. Yes. Can I finish this problem? Yeah. All right. So are we all caught up on like how we're doing this and why we're doing it the way that we are? Okay. So now it's back to section 1.1. Solve for x. Tell me what to move. You got options. What do y'all want to move? 5 from 12? Is that okay? If you wanted to do 12 from 5, would it be wrong? It wouldn't be wrong. I don't care which one you want to do. Y'all tell me which one. 5 from 12? Okay. So let's subtract 5x over here. I still have 20. What is 12x minus 5x? 7x. Okay. Still have minus 36. Now what? So you see how I have my x's now on the right side? So now I want to get that 36 out of the way. So how am I going to move that 36? Yeah, we're going to add 36 over here. So we're not crowding the variable. 20 plus 36 is 56. So now I have 56 equals 7x. Final step. Divide both sides by 7 to get that x equals 8. We have one more of these. Questions? Ask them. Yeah, just make sure you leave your phone and stuff in here. Okay. That way I know you come back. All right, let's do this guy. Find the value of x so that the figures have the same area. All right, what shapes are we working with? Well, it doesn't tell me it's a square, so I'm not going to assume it. I would say that they're both rectangles. If it had like this little symbol like this, well, that's even the same with rectangles. If it does not tell you it's a square, I would not assume it's a square. Right. Why is it not erasing? I'll do it in a minute. Yeah, so let's just assume, and regardless, the formula is the same though. So even if you thought it was a square, you're still going to do length times width. So your formula would not change. So that's good. Here we go. Let's do it. So we need length times width. So for this first guy, the area of my first rectangle, length times width, what are we going to multiply together? We have 10 and we have x. So we're going to do 10 times x, which is what? 10x. Woohoo! All right. Now let's go to my other figure, my other rectangle. We have length times width. Length times width. So this time I have a 6. What's on the other side? Why is it broken up like that? They're telling me that one piece is 3 and the other piece is x. So how can I say put all that together for this side? Let me ask you this. What if they said this was 3 and they said this was 5? How would you find the total length of that side? Come on, guys. If they told you one section was 3 centimeters, thank you, you would add them together, right? But guess what? They didn't give me a number. They gave me x. So what am I going to do with 3 and x? No, add. You're still going to add them together. We just don't know what the number is. Okay? Again, we're going to go back to that. If they broke off this section, said this was 3 centimeters, and this was 5 centimeters, how long is that side? You would say 8, right? Because you would add them together. But they did us dirty. They didn't give me a second length. They just said 3 and then x. So I'm going to do 3 plus x for that side because I don't know it. But I still have to add them together. So 3 plus x. That's how I get that total length. All right, now what? Distribute, yes. What is 6 times 3?
18.
And then 6 times x? Thank you, 6x. Okay, do we have our 2 areas? Yes, finally. I'm waiting. So what are you about to do with those areas? To find the x that works for both of them, to make them the same. When it says same, what are we going to do with our equations? What have we done for every problem today when we have 2 equations?
Combine it.
Make them equal to each other and combine them, yes. So it wants to know when do they have the same area. So we're going to make our areas equal to each other. Area equals area. So we have 10x equals 18 plus 6x. What would you like to move first? The 6, yeah? How do you want to move it? All right. Subtract it from the other x. 10 minus 6 is 4x, good. We're equal to 18 on the other side. Now what do? We divide. 18 divided by 4, it's not going to be a whole number, but it's not that bad of a decimal. What is 18 divided by 4?
5 or 4?
It's in between there.
6?
No, it's in between 4 and 5. It's actually 4.5. Did you get that? 4.5. Because 16 over 4 would give you 4, right? And then 20 over 4 would give you the 5. So you were good to know it's in between one of those numbers. It's definitely in between them. Good. So if we had an x value of 4.5, their areas would be the same. Okay? A nice bonus question would be, and what is the area? Meaning I would want you to plug it back in and see what the areas would match up to be. What's up? Hold on. Questions for me right now with the word problems. Okay, I'm going to use these 5 minutes to stamp your papers for today's notes. So let's go ahead and get your stamp paper out. Keep your notes out. This will be your final stamp. Honestly, I'll give you a stamp for doing your baseline test. So you can get 2 more stamps.